to the channel and back to the tutorial for DeepLearning. Today I am going to discuss about transfer learning with Python after a very long time. Today we see the first part, that is how we can use and achieve the image classification. That means visualize the images with the help of transfer learning here. Whenever like the channel, please subscribe and share with your friends. So transfer learning, or you can say the other term called fine tuning. What is meant by transfer learning? Transfer learning is one of the familiar machine learning technique where we can train the models with one task and again reuse the same task for some other purposes. And with the help of transfer learning, we can improve the performance of the network and time consuming also. So if you want to train newly the models, it may take long time, but if you use the transfer learning, it's very easy for you. That means pre-trained model is there, you can go train and reuse the models here. So what we can do here? So with the help of this one, we can implement how we can utilize for image classifier. So we are going to use the image classifier with VGG16 model, and here the step number 1, we have to initialize the matplot, then import the path also, then we have to packages like random, ram, and numpy, keras also, then Tensorflow is the backend here, and we are going to use a dataset here. So if you want to get the dataset, you can run the download script or use the coding, that is /wget. So here we have a lot of images there, probably 100 and above categories also images will be there. After this one, we can check the data folder. With the help of that, you can write has echo for downloading the 101 object categories. Then you can check the list out also, load the file. Then after that, you can fix the root path for deducting and visualizers one. So here the images varied according to the objects like background vehicle or motorbikes or atlas faces also. Then we can use the train and test data. Then we are going to use the useful pre-passing data into an image and input the input vector. How we can achieve the pre-passing? You can write the function called helper function, where it is helpful to get the image path. Then we are applying the NP, that is numpy array, and performing the pre-passing. Once pre-passing, what will happen? The image will move to the size of 224 by 224 here. Then we can load more images from the root folder, where you can write data is put initially. Then we can set the for loop and count the number of classes if you want. Then we can use random.shuffle.data, because whenever you want, you can take the data and visualize the images. It may be random also. Then we are going to must create training, testing and splitting also. Here for training, we are considering the 70% of the data, and validation we are taking 15%. At last testing, we are using the 15% data. So we can write the coding where follow about train data, validation data, test data, and can separate the data for the labels very easily, where you are assigning the code and writing like this, and pre-passed data as I told you, and we can normalize the data with 0 to 1, writing the normalized data with information, then converting the labels to one part vectors, and then this is the one. What we done means, till now we completed training over, validation over, testing over, training the data shape is over, at last training the labels also over. So we have more than 1,000 of images. From there we are running this one, and we are going to few sample images. So if you want to view the sample images or visualize the images, you can write the code very simply. This part-1 video, images equal to os.path, then we are writing images equal to image.load image of, at last we can write plt.figure of, at last write contact of images. So if you complete the coding and execute it, we can view the images like this. This is the images where we are achieving with the help of VGG16 with a combination of transfer learning. I hope that you understand the video. Second part will continue later. Thank you for watching. Thank you.